Hey folks, how's it going? Today I am going to be talking about standardizing ranges because I accidentally wrote a paper for standardizing Cartesian product, and I'm also try to implement the stride view, which can stride like take the every second element of your range, or every third, or every nth, whatever. So one cool thing before I get started is I'm going to be using Visual Studio 16.10 Preview 3 today, which is both feature complete for C++20 in the compiler and also the standard library. So that's really cool. I'm excited about that. It's the first toolchain to be feature complete for both compiler and standard library for C++20. I think that's cool. So yeah, Cartesian product. So I implemented Cartesian product on stream a couple of weeks ago, and thanks to the follow, Miss Chinook. And then Barry Revson tweeted at me being like, hey, do you want to write the paper on it? Because someone needs to write a paper to put this in the standard. So I was procrastinating one day and ended up writing this paper. But the basic idea, so I wanted to kind of go through a little bit of this because I think some of the design decisions here are kind of interesting. So if you're not familiar, Cartesian product is essentially, gives you all of the possible tuples of all of the ranges that you give it. So if you give it n ranges, it will give you all n tuples of those ranges. It's kind of equivalent to, if you have 3 vectors and you take nested loops, it's going to do the same thing. But it's a lot more useful for cases where you're like going to be piping it into something else, or if you're dealing with parameter packs. Like here's something I wrote to, if you want to find the tuples in some parameter pack which satisfy some predicate, then with Cartesian product you could do it like this: just get the Cartesian product, filter it, and then dump it in a vector. Whereas if you want to do it without this, then you have to. This took me like an hour to write, and it's horrible. No one should write that. But the reason I wanted to show this paper is mostly because of the design decisions. These are the kinds of things you need to think about when you're designing and writing ranges. So like for Cartesian product view, because you're going to be revisiting elements, like this loop is going to go around a bunch of times because it's nested inside these other loops. So you need to be able to revisit elements of your range. So that means that the Cartesian product view is required to be a forward range, i.e. you can save any iterator and then carry on going. There's also the question of like, what should dereferencing an iterator return, right? Because like here, this could be a tuple. What if I only give it 2? If I give this A and B, what's it going to return? Is that also going to be a tuple? But then you could make it so that if you only use 2, then you could make it a pair. So that's what I do in this paper. It's also what zip does. There's also like, what if you have an empty Cartesian product view? Like, when would you ever need that? Mostly when you're dealing with, you get a parameter pack from somewhere else, and you don't know how big it is. Like that could have been filtered out from somewhere else, or maybe some other algorithm just took stripped some values out of that parameter pack and then forwarded the rest on, and you end up taking a Cartesian product of 0 views. That's something which can happen in generic code, so I deal with it here. Then the interesting parts for me are like these things. So common range is one where the begin iterator and the end iterator are the same type. So like all of the standard containers are like that, right? If you take the begin iterator of a vector, that's the same type as taking the end iterator. But it's not the case for some views, like cycle, for example. If you take the begin iterator of cycle, that's not going to be the same type as the end iterator because there's no meaningful state for an end iterator of a cyclic range. So that's what a common range is. But then if you have a Cartesian product view, like when is that going to be common? When is the begin and end iterators of that view going to be the same? So in this case, it can be common if all of the underlying ranges are common, or if all of them are sized and random access, which basically means that you can grab the end iterator just by calculating the size and then jumping to it. So that's common range. Interestingly, is bidirectional. So with Cartesian product, bidirectional range, your Cartesian product view cannot be bidirectional if the underlying ones are just bidirectional. They also have to be common. The reason being, say you grab this for now. Say you have like a vector of 1, 2, and 3, and you take the Cartesian product of 3 of these, right? The idea is you want 0, 0, 0, and then you want 0, 0, 1, and then you want 0, 0, 2, and then 0, 1, 0, so on and so forth. The question is, like, if you're here, right, if we currently have an iterator to this position, what happens if we go backwards? Well, then we need to work out where the penultimate, or sorry, the last element of this final range is. And in order to do that in a way which is constant time, then the underlying range also has to be common as well as bidirectional. So those are like some really kind of parts of ranges implementation and design which can seem really kind of nitpicky and obscure, but they can really make a difference. But then it can also be bidirectional if the range is non-common but random access and size, and I can't think of many cases where that actually matters. So in this paper I just said we don't deal with it. And then random access, Cartesian product, you can jump anywhere so long as the underlying ranges are random access and sized, because you need to know where to jump to. You need like modulo of the size of these ranges. Now, another interesting thing with Cartesian product is the initial range, right? So like, if we have our case again where we have just this vector 0, 1, 2, this first column is only going to go 0, 1, 2. It's never going to go backwards, right? So it's a special case because all of the other ranges are going to have to cycle round. The first one does not, which means that the first one could be an input range instead of a forward range. Additionally, it wouldn't need to be sized for our view to be random access or common, and it wouldn't need to be common for this to be bidirectional because we never need to seek backwards over the end, which is kind of interesting. So you get to these cases where you're thinking, is it worth special casing the first argument to Cartesian product view in order to get these relaxations to allow you to pass an input range as the first one, like an iStream iterator or a generator type? Or do we go for the case where we want consistency and we don't want to special case things? I like the consistency there, but people disagree. Thanks to the fellow user 404D. And then the last thing I want to touch on is sizing. So Cartesian product view can be sized if all the underlying ranges are, because you can just multiply all those sizes together. But the interesting thing is what's the type of size, right? When you return the size, you're going to have to take the product of all of the sizes, and that could overflow the widest common size type of all the underlying ranges, right? Like if all of your underlying ranges have a 32-bit size, say, size type, then if you multiply all of those together, you could quite easily overflow that 32 bits. So your size type for Cartesian product might need to be larger than the size types for all of your underlying ranges, which is interesting. I think here I basically say see below, and then I say the return type's the smallest unsigned integral types sufficiently wide to store the product of the maximum sizes of all underlying ranges. So you get into some bizarre corner cases, but this is something you have to care about. Like, sometimes overflow is something which like might happen on the boundaries of reasonable use, but for Cartesian product, if you have 5 ranges and you multiply all those sizes together, you could quite easily overflow your the size type for the underlying range. So anyway, that's all I wanted to touch on here. If anyone has any questions about writing a paper like this, like there's a lot of papers for ranges which need written, and the most important parts are things... Oh, hi, Kitty. Kitty. One of the most important parts are getting this design and thinking about it. Like, the wording and stuff is kind of not that interesting. It's mostly the design. So if you're interested in writing one of these papers, I can put you in touch with people who can help. Anyway, that's all I want to say on Cartesian product. So let's go for stride view. I'm just going to delete all this. Okay, so a stride view is basically one which... Oops, stride. Yeah, I'm using BikeShed to generate the documentation. It's quite nice. It just takes Markdown, and then it generates you like this table of contents, and can do tables, headers, link between them. It's pretty cool. Yep, so stride. Hash include catch to. Yeah, BikeShed. Okay, I'll just call this stride for now. So stride view, say we have a vector of ints, and do 1, 2, 3. I could generate this, but I'm just going to type it out while a cat is trying to nuzzle my hand and making it very difficult for me. Hi. Yes, you're very sweet. Let's do that for now. Okay, so say we have a vector from 1 to 6, then... oh, sorry, yeah, the meaning of BikeShed is like, yeah, arguing over insignificant details, which often happens in the standardization process. Spending like 3 hours over what we should name this thing rather than what it should actually do. Not that naming things is not important, it's very important, but sometimes the details can get a lot of time spent on them. So let's say we take this and we want to stride this vector, so we could say pipe v into tl stride and take every stride over it at an increment of 2, which means that this would get 0, 2, 4, 6. If you did a stride of 3, then it would be 0, 3, 6. Alright, makes sense? So that's what our use case is going to look like. For now, I'll just output it. And also, because the piping is more difficult than everything else, I'll just do it like this for now. Stride view of v2. So this is what our initial use case is going to try and look like. Stride.hpp. Alright, so now is the case where we've got a lot of boilerplate to write, and I don't want to write it all. So what is the closest cousin to stride that I can copy paste from? It's probably cycle. So I'm just going to take cycle and copy paste it into stride so that we've got something to begin with. Yeah, I haven't watched Chris's talk on stride. Whoops. So I might be in for some surprises. Like, my understanding of stride is the difficult part is, if I'll go back to my test case. So most of stride is kind of simple, right? Like, when you increment, then you just increment the iterator by whatever this is. But the difficult part, at least in my understanding, is say we set a stride of 5, then we would start here, we'd go 1, 2, 3, 4, 5, and then say we increment again. Right, that will take us to the end. Now what if our underlying range is bidirectional and we want to go backwards? Well, we can't just start at the end and go backwards 5, because that will take us like here. That would be wrong. So there's a few possibilities. One possibility is when you're at the end and you decrement, then you could originally keep track of your offset. So when you increment from this position, for example, and get to end, then you store that you've still got one element that you're offset by, so that when you decrement, you only offset by the one element. Or if the range is sized, then you could just compute it modulo the size of calculate the difference between begin and end modulo your stride, and that will tell you where you need to end up. So I think those are the two cases. So you're going to need to do some special casing for bidirectional. But apart from that, I don't think it should be too complicated. Right, so Vuvov is saying, what's the flow you choose for developing a new feature? I tend to, it depends what I'm doing. For this stream, I write very basic tests first because I just want to get something written. Usually, I would rather write more complex tests, especially because that means you think about things like this, right? Like those edge cases where you increment off the end and then have to decrement. So, just going to replace cycle with stride. Phenomenal. Okay, so cycle required forward ranges. I don't think we need forward ranges. We only need input ranges because we're never, we're not having to cycle around or anything like that. We can just go straight to the end. So stride view just requires input ranges. Okay, so let's do our, what does our iterator need? So our iterator will need the underlying iterator. We probably don't need a pointer to base, but I'll leave it in for now. We definitely need the stride. So the stride, what should the type of the stride be? Probably the difference type for the underlying iterator. Is there something in ranges which will give us that? It's probably an iterator header. I want the difference type of the underlying range. Or that, actually, that's probably in ranges, isn't it? It's probably like range difference t. Something like this. Range difference t. There we go. Std ranges range difference t for base, and that is going to be our stride. So we're going to capture our stride in our, I'm going to delete this. I can't think of why we would need a pointer to base in our striding view, so I'm going to delete that. And then we also need our stride in our constructor so that we can capture it. Just copy that in here. Okay. This is our converting constructor. So the iterator can either be a const iterator or a non-const iterator, and we want to be able to convert non-const iterators to const iterators. That's what this function does. Just copy i.stride into stride. Okay. So for incrementing, we just do, instead of ++ current, we're going to do standardising advance current by stride. So this will just increment current by stride. Now, this is probably where we need to start thinking about have a extra base after stride in line 31. Yes, thank you, Sabanasu. Okay, so this is where we need to start thinking about keeping track of our offset, right? Because we want to advance by stride. We only want to go as far as the end. So we can say last is standardising end of... Oh, we do need our base pointer. Never mind. Because we need to be able to work out what our end is. Just take this here, base pointer base, and then store it here. Okay. Let's take the end of our base that's going to be last. So now standardising advance can take a bound, which is essentially where to stop. We either advance current by stride or until current is equal to last, and that's going to return us the amount which we actually went. So now we're going to have to try and store this somewhere. So we only need to store this if we are bidirectional and we're not sized. So what I think I'll do is I'll make a base class for this, and I'll customize the behavior there. So let's say we're going to have a member function called setOffset, and that's going to be the amount we actually incremented current by. Okay. This is fine. This is fine. This is going to need to be changed. Okay, let's do this setOffset thing. Okay. So we'll make a class called iteratorBase in here. Oops. Not sure if this will need to be templated or not, but we'll stick with it for now. Okay, so iteratorBase will be dependent on whether we are sized and bidirectional. So bool standardising ranges bidirectional range. So if v is bidirectional, then this will be true, otherwise it won't. And also standardising sized range v. This also has to be dependent on const, which is kind of icky. I guess we can say our base type is just copy this thing. Our base type is either, const v or v, and then here we say base, and here we say base. In fact, can I partially specialize these based on we'll see what if I get an error or not. Okay. So we're going to have a few cases here. We're going to, if we're bidirectional, then we need to have an offset, which is going to be the same type as our stride and be called offset. And our set offset function is going to take, can I make an alias for this? Call it difference type. It's going to take difference type, called off, and it's going to set offset to off. So this is going to be the case where we are bidirectional but not sized. Then we're going to need a get offset, which is going to, in this case, return offset. Okay, so now we need a specialization of iterator base where we are maybe const, we have some base, we are bidirectional, we are also sized. So in that case, setting the offset does nothing. And getting the offset is going to calculate it based on our underlying iterator. Based on our underlying range, even. And, this one is going to be a specialization as well, because our basic case has a couple of options, because we have true, 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 false, false, true, false, false. So this is the case where we are bidirectional, but we are not sized. And the basic case where we're neither bidirectional nor sized, we don't care about offsets at all because we're never going to be decrementing our iterator. So both of these functions do nothing. I guess we have to return something technically here. I guess we just return 0. Okay. All right, so I think all of these iterator bases are going to require a pointer to base and also current and stride. This is where we're going to store everything, I think. So only our bidirectional but non-sized one has an additional offset type. Yeah, get rid of that. Okay. So how do we calculate our offset for the case where we are both sized and bidirectional? Okay, so if we go backwards, where are we, stride? If we go backwards from the end, then we're going to take the size of our range modulo the stride. I think that's correct. So In this case, the offset is, so we start here, we go 1, 2, 3, 4, 5, and then the offset is 1. So let's work out the maths. So in this case, the size of the range is 7. 7 modulo 5 is 2, but we want 1. So I guess we take the size of the range modulo modulo the stride, but we also need to take into account that we start off with the first one, so we add the stride and subtract 1, I think is correct, which is 11 mod 5, which is 1. Aren't we going back from the end, so 2 is correct. But we start here. We are going back from the end, but the idea is that the stride view should always be consistent no matter whether we start at the start and increment or start at the end and decrement. So, and it should be the same. Like if we start here and then we go 1, 2, 3, 4, 5, and then we go 1 off the end, then when we decrement, we should only go back 1. No, we can try it out, and if it's not quite correct, then we can fix it later. It's this one. Return. We don't have an offset here. And we return std ranges size. Maybe maybe. Wait, so what are we keeping track of when we increment? We set the offset to the delta, so std ranges advance. What does that return us? It returns us the number of spaces we actually went, or the number of spaces we did not move. 3 returned value, the difference between n and the actual distance traversed. Yeah, so when we, okay, so we're getting slightly different values here. So when we're here and we asked to move forward 5, then we're going to get 4 back as the offset, because that's the number of spaces we did not traverse. In this case, we're doing kind of the opposite. We need to subtract this from the stride. I think Google should develop a protocol std search function. Yeah. Okay, so we take the size of base. We add the stride, subtract 1, take that modulo the stride, and then subtract that from the stride. I'm sure there's a way to simplify this, but whoops, that should be %. We'll try this for now and see how we go. Okay, so we're keeping track of the offset in ++, which only has an effect for bidirectional non-size iterators. And when we subtract, okay, so the amount of places we want to move is our stride. So we can say the delta is negative of, I guess now that stride is stored in a dependent base class, we need to use this everywhere, which is always fun. Negative of this stride. So that's the amount we want to move. And the amount we actually move is only different if we are at the end iterator. So if we are at the end, so if current equals standardisation end of base. So if we're at the end, then we need to modify delta by base, by get offset. Right? So in the case of bidirectional range, this doesn't, non-bidirectional range, this doesn't matter because it's never going to happen. In the case of bidirectional non-sized range, it's going to give us back the delta we previously computed, and otherwise it's going to compute it based on the size of the range. Okay. And then we advance current by delta. And we don't need to give it a bound because we shouldn't get past begin unless we decrement too far, which is not something we need to be worrying about. All right. Now, random access. So this seems a little bit more complicated. So for random access, we need to, if the difference type is 0, then we're just going to return, because we don't need to do anything. If the difference type is positive, then, hey Oliver, we're going to multiply it by the stride. Oops. And that will give us the amount of places we have to move forward. Then we're going to advance current by x up until the end iterator, which is the ranges end of base, and capture the delta and store it. So again, this is the case where we go too far. And if x is less than 0, then we are going to do something very similar to this. First, we're going to check if we're at the end, which we can do by moving this here. So if this current is at the end, then we are going to add our offset. I guess first we will multiply it by our stride, so we can just move this out. So we add our offset, and then we advance this current by x. Whoops. Hey Chaku, there isn't a plan for an in-person C++ Edinburgh meetup yet. We'll see how things go. Alright, how does this look to everyone? Looks somewhat reasonable. Pete Burns, member of Dead Alive? I don't know. I don't know them. Okay, so now is a case where we have our begin and end and all that nonsense. So I think this is all wrong. I think we want to model our begin and end after Cartesian product, probably. Oh, you spin me right around. Yeah, I do remember that. Because we're missing some constraints here. We also do want a sentinel. There's a place where I did delta plus offset instead of plus equals. Delta... where's that? Oh, here. Thank you. I'm gonna go steal some stuff from here because this has all the constraints mostly right, I think. And I'll just correct the implementations. Get rid of all of this. Okay, so begin. Our non-const version of begin requires that we are not a simple view, and we will pass it our stride. What was the order which I put these in the constructor? Current, stride, base. So std ranges, whoops, begin of base, and then stride, which we'll capture later. Okay. Then our const version requires that const v is a range, and otherwise we do the same thing. Thank you, Y Spider Monkey. I'm not gonna buy any followers, but your comment is appreciated. Gonna go ahead and delete that. All right, and then end. Okay, so there's a few cases of end, right? There's the case where where v is not a simple view. A simple view is one where the const iterator and the non-const iterator are the same type. So in this case, we want something which is not a simple view, but is common, which is std ranges common view e. So this is the case where the non-const iterator is different from the const iterator, but our end should return iterator rather than some other sentinel type. This stuff gets hairy. You think like getting the begin and end of a range is easy? It's actually not. This case is for when we are simple view, we are a range, const v is a range, and const v is a common view. Okay, and then we need the cases where this is not true. I'm just gonna copy paste these. So we are a range, we're not common view, we are not a simple view, we're not common. In that case, then we're going to return a sentinel, which we're going to have to write. Okay. Sentinel. Where can I steal a sentinel implementation from? I don't want to write one. This one. Fine. Dump this under our iterator. Okay. This is stride view. Otherwise, stride view. And we are the sentinel of our parent. Okay. Comparing the sentinel should compare current to end, and we should be able to convert the constness of our sentinel. Okay. That looks reasonable. Yes. Okay, so now we got, like, what's that, 6 begin and end functions? Hey, Biddle. But that should be all good. Okay. So when we create a stride view, then stride view is going to take some range, and it's going to take the difference type for that range. For R. Think that is right. Now, do we need to be able to customize the difference type? Probably not. I don't think we do. Okay, and then we have a stride function, then that's going to take a viewable range and ranges. I just forgot to hash include ranges up the top or something. No, weird. Std ranges. Yeah, this is not difference type, this is range. Difference T. Range difference T of V. Just call it D and construct that here. Okay. Piping. Piping I'm not going to do for now. We'll get this working. Get the default case working first, and then we can get piping working. Okay. In addition to base, we need std ranges. Stop doing that. Range difference T V, and capture that as the stride. And then have that as a member up here, wherever we are. Of V stride. Cool, cool, cool. I think we're looking pretty good. Let's try compiling this and see how we get on. Any of this need changing? Our iterator category is the same as the underlying one. I think that's probably true. Reference, value, difference type, all the same. Yeah, seems reasonable. Okay. What happened there? Okay, we need to actually include TL stride. And and include IOStream as well. Cool. Okay, what else could go wrong here? I feel like, do I need this constructor and all those base classes? I probably do, don't I? Difference type is not being declared. You are correct. Just copy paste, copy paste, copy paste. Well, thanks to the YouTube channel. Channel helps you understood hard stuff. Yeah, thanks. I'm glad it helps. A video review the best features I like in C++. Yeah, I could probably do something like that. Could get Marshmallow to help. Same here. No, we do have a difference type there. Same here. Oh, did I miss the return type for the other one? Yes. Always up for more Marshmallow content. Yeah. Okay. Yeah, I do need to move this constructor stuff into the base classes. Oh, I forgot to inherit from iterator base. That would help. I think I still need to move the constructors, but at least this will give me a different compiler error. Always fun. I'm trying to remember if this partial specialization will work properly. See how it goes. Okay, still does not have any field. Yeah, let's move this stuff into base class. Just copy paste it into all of these. Whoops. That should do. And then in here, instead of directly initializing all of them, I do iterator base. And just pass all of those as arguments. And that should be, whoops, base. There we go. Almighty Rum says, see a lot of posting for C# devs, a lot of difference between that and C++. Yeah, like SFDB says, C# a lot more similar to Java than C++. Because C# is managed and C++ is running the hardware. C++ has all of this template stuff, which, to be fair, you don't need to know if you're doing application code for the most part. But yeah, C# is very similar to Java compared to C++. Trying to get GCC code to compile on MSVC. Yeah, our compiler errors will be getting better. Only decorations. Oh, I forgot to rename these constructors. Constructor has to have the same name as the class, otherwise it is not going to work. Yeah, C#. I have seen justification of the naming of C# coming from C++++, because that looks like a hash if you stack everything on top. Does not have a member iterator base. You are lying to me. What's the advantage of making multi-argument constructor explicit? There is none. Copy-paste job. What are you talking about? It does not have field named iterator base. It's a base class. Do I need to give it the template arguments? Should be injected class name, no? Where are we? Sentinel is not a template. Correct. Make this a template. Just make it a for declaration. Do we make this a friend at some point? So many friends. Whoops. We should make a friend down here. Sentinel. Oh, what's the syntax for that? I can never remember. Making a template friend. I'm sure we've done it in one of these other ones at some point. There it is. Where were we? Stride. Whoa. Try again. Biddle says, do I consider explicit another wrong default? Yeah. Yeah. Single argument constructors, you should have to opt into implicability. Otherwise it's just a nightmare. What are you talking about? I don't have a field named iterator base. How about now? Is this gonna work? Okay, that's better. I dot current. This is the const converting constructors. Do I need to move all of these to the base as well? Probably. No, I can just construct iterator base non-const with current and stride and I.base. I think that's legit. Okay. And it's going to complain a bunch because, right, so when you have a base class, which depends on a template argument, which we do, and your member is stored in that base class, then you need to prefix it with this, or explicitly say which one you're using. So I'm going to have to do that here, here, here. Okay, there are no arguments to get offset, which depends. Yeah, so I need to make that because this is, again, this is a dependent name. I need to explicitly say that it's a member function. This must have exactly 2 arguments. What are you talking about? Okay, yeah, this needs to be sentinel const. Auto parameter is not permitted in this. Thanks for the subscription, Taras. Where am I using auto wrong? Oh, it's just because I didn't give the template parameters. Simple view is not declared. What did I need to hash include common.htpp because that's where I defined simple view. Simple view is just here. Iterator for R is the same type as iterator for const star, same as the sentinel. Stride, what else? What else? What else? Yeah, that should go away. Just gonna. Yeah, so the most interesting parts that we've done so far, I think, is dealing with the cases where we are bidirectional but non-sized and bidirectional and sized, and doing all of that with dependent base classes. What's going on here? Yeah, it's fair if you still think the offset logic is wrong. We can debug that later. What is wrong here? V is not simple view. What namespace is simple view in? not in detail, so we should be able to find it. Anyone see what the syntax error here is? Erroneous expression. Is v the right name for this template parameter? Yes. Any ideas? It's quite a lot of code for something which is just skip over n spaces. I wonder if this is going on here. Expected primary expression before. I'm not seeing what's wrong here. I guess I can try fully qualifying this. Oh wait, it was only this one which is going wrong, right? Std ranges common. Oh, common range. Common range. Not common view. That'll do. Yeah, while GCC's compiler errors are generally much better, this was a case, could have been a little bit better there. Could have said, what on earth is this common view thing? I have no idea what you're talking about. Whoops. It's to underscore. Set offset was not defined. This, there we go. Yeah, so the compiler bug the Boodle is talking about last time was using a requires expression in a context which was not a concept definition or a requires clause. These are all in requires clauses. Like if I had requires, that was in a requires clause and that works. MSVC seems to have a bug of using requires expressions in like if context per blocks, things like that. I emailed the devs just actually earlier today to say, is this a known issue? Template constraint failure. Okay, so now we're getting the nice compiler errors. Constraints not satisfied. Right, it's not a sentinel for the stride view, it's a sentinel for V. That should be better. JavaScript, you write code, run it, and mad. With C++, you write code, compile it, and mad. Yeah. Lots of mad. Unused parameter off. It's fine, we can just remove that. Okay, what else? What else? Wait, where did this fail? That's warning. Internal compiler error. Oh, that's in something different. That's fine. Oh, did this work? Just gonna. For some reason, it doesn't like to populate the startup item right now. I know an issue, you say, Sebastian Yuzu? Yeah, maybe. I do want to get that fixed though, because it can be really handy to just stick a requires expression inside of context to be like, hey, if I can do this, if it's syntactically valid, then I want to do it. Otherwise, do something else. Without having to come up with a concept name for it. while this is building, when we think about coming up with a test case for our offsets. Right, so there is 3 cases for the offset. There was the case where you are non-bidirectional, which we can't really test for because it shouldn't make a difference. There's a case where we're bidirectional and sized and bidirectional and non-sized. So bidirectional and sized std list is bidirectional and sized. What is an instance of a bidirectional non-sized range in C++? Can anyone come up with an easy one off the top of their head while I run this test? Filter view. Is filter view bidirectional? Have to check. Std ranges, filter view. Filter view. Oh, it is bidirectional. That could work. Yeah, because it won't be sized, because sized has to be calculatable in constant time. Yeah, that would work. Good idea. Thanks. Alright, did this run? Oh, it's still building. Yeah, so we could have a std list events 0, 1, 2, 3, and we could see what this does. Yeah, a filter view that includes all the elements just returns true. Switch to MSVC. Before we do that, let's just make sure that this default one works. Where were we? Yeah, so the offset. Let's go and quickly look over our logic whilst this compiles. So when we save the delta, then that is the amount of space we did not traverse, which means we need to subtract the offset from the stride, which is what we do because x is negative in this case. So I think that's correct for the non-size version. I think, Seth, what you're saying is that my logic for this is wrong, which is very, very likely. Ooh, what's going on here? Error, object reference not set to an instance of an object. Eesh. Well, you just go delete that cache. Regenerate it and see if that gets you back on your feet. Right, so what do we want this to be? We want the oh, we forgot to calculate size of our range, actually. We should have an implementation of size. Which looks like this. So size requires that it's a sized range, and we should also have a const version, which requires that const b is a sized range. Okay. So I guess we need to do a similar calculation here anyway. So testing for the stride 5 case and the 7 size vector, you need to go back to element 5 while you're at the end. So the distance needs to be 2. Where's my test? So we're here and we go 1, 2, 3, 4, 5. All right. Yes, you're right. So what does the calculation need to be in that case? It needs to be just the size mod, the stride. Yes. So in our, where are we? Here. Yeah, you're also subtracting the offset from the stride and the offset. Yes, you're right. So this should just be size mod stride, and that's it. Is that correct? Anyway, that is finished generating CMake. All right, yeah, so this will be 2, but we want the because we're doing the subtraction and the minus minus, so yes. Let's just see if this builds and this succeeds, and then we can go and fix that. We have like got a fair old library of ranges implemented now, which is kind of cool. And one thing you will notice if you're here for the Cartesian product stream is that I cannot do maths on stream, nor in general anyway, but being on stream does not help. Oh, linking. Okay. We built stride. So hopefully we will see, what is it, 0 and 5 printed out when we run this. Come on. Okay. That did not print anything out. Which is not what I would have hoped. Did I miss something? Let's debug this. Oh, I might have got the equality comparison to the Sentinel. Might be wrong. Yeah, that doesn't look right. So when I compare an iterator to an iterator, should compare current to current, that's right. I feel like we have in our Sentinel implementation, right, that looks right. Oh, thanks, Epic Armor. Yeah, some of the code gets kind of hairy, especially things like this. It kind of requires you to have written it a few times, and then you kind of get the patterns in your head, like, oh, the const version should check it's not simple view, and the non-const version should check it's a range, and all that stuff. See if this prints something out. Did not. Well, that's no good. Anyway, it should be comparing against iterators. It shouldn't be comparing against Sentinel because the std vector is a common range, so it should have picked this overload. So what's going on? When we advance by strides. Let's just stick a breakpoint in here and stick a breakpoint in our equality. And what about our operator star? Yeah. So x.current and y.current are the same. That's wrong, clearly. Oh, we are not initializing. That would cause it. We do not want to initialize our end iterators with our begin iterators. That gives us the wrong answer. So another option for the, this is another area where the design for these things becomes interesting. Like for doing the sized or non-sized, we could just calculate the offset once when we construct this thing and then store it somewhere. So there's a trade-off between having an extra member in here or doing this maths every time you call the getOffset function. But my trade-off here is that you only call the getOffset function if you call operator minus minus on a bidirectional iterator which is sized and you're at the end iterator, which I think does not necessitate adding an extra member into our iterator types. I think that's the correct trade-off. So this looks better. 0 and garbage. Garbage in end iterators is always good. And then plus plus, current should end up at 5. Current ended up at 5. That looks good. Let's remove these breakpoints. Move my camera so I can actually see where my breakpoints are. There we go. Continue. Alright, also end iterator get for a non-sized bidirectional iterator might need to set the offset somehow. Yeah. Okay, what did that do? I missed that. It should drink water every time. Yeah. Oh, there we go, 0, 5. Okay, that's good. That's good. Okay, let's make this into a proper test case rather than just printing stuff out. I can just say int I equals 0, and then I plus equals 5, and require that e equals I. You know, I'll make this 3. I'll make this 3. I'll do for initial test. Stride view of some bidirectional non-size 3.end is not decrementable properly. Is that true? Yes. You're right. Because in order to work out what the offset is for a non-sized bidirectional range, you would need to have calculated it beforehand, which maybe means that our do you think that means that bidirectional non-sized stride views should be non-common. That's an interesting design decision. So having bidirectional non-sized ranges as non-common would mean that if you called end, you couldn't, like trying to decrement the end iterator wouldn't compile. So I think that's probably the right design decision, right? Yeah, I think we should do that. Tara says, implement opportunity for the user to decide which side of these things, the trade-offs you should take. Yeah, you could technically do that. Yeah, you can. So this is it's a design decision. So do we want to allow people to decrement the end iterator of I think this is correct. So when we call .end, then we require, in order to return an iterator instead of a sentinel, we require that our underlying range is not a simple view, it is common, and either it's not bidirectional or it is sized. Right? Is that the correct constraint? So ranges bidirectional range V or stood ranges sized range V. Okay, so we're saying in order to return an iterator instead of a sentinel, we require this to not be a simple view, require it to be a common range, and to not be bidirectional or to be sized. Is it better to get an iterator than a sentinel for a non-bidirectional range? Yes, because being common when you can be means you can pass these things into like algorithms which require the iterators to be the same type. So I think, yeah, it is a little bit weird that like if you pass a forward range into this thing, regardless of whether it's sized or not, then you'll get either an iterator or a sentinel. But if it's bidirectional, you only get an iterator if it's also sized. This stuff is hard. It's fun though. In this case, we need to make it const. We should really make this a concept. Give it a name. Yeah, let's take this and say stride view is common for V. Is common for const V. And then we'll call this detail. All the way up here. Let's say namespace detail. So for some class V, then stride view is common if it's common range and it's not directional or it's sized. Concept. Cool. Yep. Is that all good? Concept is undefined. No, it's not. All right. And then I think we need to make some more changes down here. This is not detail stride view, is common v, and not detail stride view is common for const v. Cool. See if this compiles. Buval says, I want to use a library on C++ 11. Can I use C++ 20 for the main source code? Sure. I think like there's some small breaking changes, mostly in context for member functions. If your C++ 11 library has context per member functions in its types, then in C++ 11 that implicitly declares that member function as const, whereas in C++ 14 and forward it does not. So that's one potential incompatibility. Otherwise, yeah, it should be absolutely fine. Okay, that passed. Okay, let's write those tests for our offset. So let's say our view is TL stride view for list and 3, and our iterator is v.begin. Okay, so if we can require that dereferencing this iterator starts off 0, that incrementing it sets it to 3, then incrementing it and then decrementing it, whoops, so it is 3 again. Okay, and then I'll scope that, and we can do the same thing, but first pipe this into std ranges, std views, filter with a function which always returns true. And do the same thing. So this should hit both of our cases, our bidirectional sized range and our bidirectional non-sized range. Let's give that a try. We might even get compiler errors here because we're hitting different parts of our code which have not, different parts of our templates which have not been instantiated. Oh, that's not giving the filter to the stride view, you're right. I'll pipe to filter, there we go. Then once we get this working, we can implement piping and then we'll be done. Might still have 20 minutes left. All right, let's see. Okay, failed. So my maths was wrong. So what should this thing be? So currently, wait, which one failed? Did the first one succeed and the second one failed? Because that's what I'm expecting to happen. Line 27. Oh, this one failed. That's interesting. Because this one we are saving the offset. Okay, let's stick in some breakpoints. Stride minus size, mod stride. Yeah, but we shouldn't even have hit that. Oh, the first one's the size one. You're right, yeah. Okay, yes. Here, stride minus size mod stride. Okay. Come on, come on. All tests passed. Very nice. Cool. All right. Let's try and implement piping then. So when you call this with a viewable range, it should give you back a stride view. When you call this with some integral type, then it should give you back we'll call this stride view closure. And then stride view closure stores some integral type. And it has a bar operator, const expert auto friend, or is it friend const expert auto operator bar, which takes our viewable range and our stride view closure, and then returns a stride view of v and stride. Forward it here. TL return instead of returns. Okay. And that should give us our piping syntax. Which should allow us to do TL views stride with 3 and just straight up pipe V into it. Compile, see what it does. Okay. Oh, whoops. Yeah, being able to use requires to select member functions is such a nice addition. Because, like, oh, whoops, I forgot to implement size. Let's just do this first, and then we can write some tests for size. All tests passed. Amazing. test case for size is we'll give it vector and say auto stride 1 is TL views, or sorry, v pipe to TL views stride of 1, then require that the size of S1 is 7. And then can do this for a few different ones. So in the case of 2, should go 1, 2, 3, 4. In the case of 3, should go 1, 2, 3. In the case of 4, 1, 2. Oh, whoops. And then these should be 2. Okay. So the implementation, is it straight up division, size divided by the stride? Not quite, is it? Because here it should be 4. 1, 2, 1, 2, 3, 4. I think it needs to be the size plus the stride minus 1 divided by the size, by the, oops, stride. I think that's right. Give it a shot. Return ranges size of base plus stride. I don't need this in this case because here I'm not in my dependent base class hell. Get that shot. Not failing math would be a strange thing. Thank you. Illegal indirection. Illegal. Going to jail. Oh, because base isn't a pointer here. And then I'm pretty happy with this. I think we've got some, like the fact that we properly handle whether we're common or not and stuff is, like that stuff is pretty detailed. Okay, failed. 7 equals 4. Is the test wrong? Line 31. Okay. I guess my maths is wrong. So in this case, it would be 7 plus 2 minus 1 divided by 2, which does equal 4. Let's take a breakpoint in here. S1. Oh my god, you're right, yeah. Yep, my test is wrong. Come on, give me my tests. There we go. Helps, doesn't it, if your test is actually testing for the right thing? And if this works, we've still got 20 minutes left, so if any of you want to see anything else in here or try any small things, you can do that. Okay, thanks for the follow, Dimagesh. Oh, I don't even need this unless it's going to go wrong. All tests passed. Amazing. Maybe we can write some comments. Because someone's going to have to specify this for the standard. Any comments we write in here I can pass these on to people if they're useful. So when we describe why stride view can only be common if it's non-bidirectional sized. So stride view can be common if the underlying range is not bidirectional, but if it is bidirectional, then it is required to be sized because, split this up a bit, and the reason was because working out where to go when you decrement the end iterator requires computing the offset. Okay. And then we can also comment our iterator-based stuff. So, case when underlying range is not bidirectional, i.e. we don't care about calculating offsets. Then this is the case when the underlying range is bidirectional but not sized. We need to keep track of the offset if we hit the end iterator. And then this is the case where underlying is bidirectional and sized. Can calculate offsets from the end on demand. Okay. I think that's pretty good. Anything else missing from this? Why don't we try piping... Wait, we can do a few more stress tests on this. We can try piping it into other views because that can often break if you don't do something correctly. Longer pipeline. So what happens if we take our stride, so we take every third element of this vector and then we std_views transform it, and multiply it by 2, say. So this should give us 0, and then 6, and then 12. Cartesian product of 2 strides. Yeah, that would be another one we can do. Let's try this first and see if it works, and then we can try composing it with Cartesian product just for funsies. So in this case, E should equal I times 2. We have not included ranges. No, didn't get there in time. References must be initialized. What was I talking about? Missing a bracket. There isn't a link to the paper for Cartesian product yet. I have submitted it to the standards committee, but it hasn't. It'll make it into the next mailing, which should be, I'm not sure when. This month sometime. Here we go. That didn't compile. That's not fun. I'm not going to find that issue with MSVC. Let's compile the GCC and see what constraints we fail on. So the problem here must be that stride is failing the constraints, the stride view even is failing the constraints for std_views transform. So we could be missing some type defs in our iterators. We could have missed a default constructor. Anything like that. Okay. Substitution failed. Okay, so ranges begin failed the constraint check, so let's go and so GCC's compiler errors, they can give you more information if you specify this flag, which is very handy. I think, do I have this somewhere in my CMake lists? Guess I want this here somewhere. Target compile options. Oops. F concepts diagnostics depth. I'll set 4 for now. Okay. See if this gives us more detailed reason why we cannot pipe stride view into something else. See if we can find it by eye while it's compiling. Compare Sentinel. We can compare our iterator to iterator. So our iterator default constructible. Might not be. Okay. Now we're reading some hairy compiler errors. Okay, so right at the top here, we are failing this because our call operator fails. So we should pass this member begin check, but we are not. Member begin is unsatisfied because input or output operator is failing, because our iterator is not default constructible. There we go. Hey, thanks for stopping by, Viola. No, your questions are very much appreciated. This must be because our iterator base is not default constructible. Yeah, in order, all of your iterators need to be default constructible. Your view also needs to be default constructible. I believe there's a paper which tries to make views not required to be default constructible. Alright, how are we going this time? That seemed to work. List is not in member because we just didn't hash include it, but the rest looks pretty good. See if MSVC will compile it. Then we can try something ridiculous like piping in Cartesian product as well. Include. So what was your suggestion, Seth? Cartesian product of two strides offset by 1. Is this going to compile first? We can have yeah, it might be a bit complicated. We can try something at least. Like we can say TL Cartesian product, TL views Cartesian product of V with V. So this should give us all of the pairs of V. In fact, let's make this a smaller thing. 0, 1, 2. Hey, thanks for the follow, DJ Croissant. So we have Cartesian product of 2 vectors. Then that should be 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 1, 0. So every third one will increment that. Every 9th one will increment the first place. So then if we say TL views stride by 9 and say I equals 0, then we can require that our 0th element of the tuple we get back from our view is equal to I. So this should test that we only get every iteration of when the 0th column increments. Oh, in fact, I wanted 3 Cartesian products in here. Ah. Big compiler errors. What's going on? No matching overload found. In size. Interesting. Hey, thanks to follow Carino. Is this maybe a bug in Cartesian product we've just found? That may well be the case. Right, yeah. This is a bug in Cartesian product. Because I do not actually pass bases into std apply. Must have forgotten to write tests for size. Where are we? Here. Let's try that. Can I pass my lambda into it? Does it multiply by default? You mean Cartesian product? Okay. That seemed to... Oh, sorry. GCC can't compile my Cartesian product because... Oh no, it can compile TL2. I'm not sure what you mean by multiply by default. So std apply applies this function that we give as the first argument and takes its arguments from all of the elements of this tuple, and then I multiply all of them here. Alright, GCC seemed to compile that, so let's go back and try with MSVC. And hopefully this will work. And that'll be kind of cool. Alright, we like have a Cartesian product view we wrote and a stride view which we wrote, can pipe them together and they all work. Well, this is linking, so I guess oh, come on, stride, you can do it. Yeah, it compiled. I'll go remove that diagnostics depth from the compile options. Not that it should really make a difference. Build all succeeded. Come on, come on. All passed. I'm very pleased with this. Cool, so we implemented a stride view and it seems to work. It works for bidirectional ranges, which are sized and not sized. Doesn't take any additional space for sized bidirectional ranges. Yeah. Yeah, so the Cartesian product, the multiplication is done here. So this is a fold expression, so I fold taking the size of the base and casting it to the size type and fold that over the multiplication operator. So that's where the multiplication occurs. So apply, you could do anything in here. It just calls this function with all of the elements of this tuple. But we're pretty much bang on time. We got stride implemented to pretty decent quality, got some tests, fixed a bug in Cartesian product. Pretty happy. Thanks to follow the real Etiago. But yeah, thanks for everyone for joining in. Next time I might try and implement maybe chunk or maybe slide, which gives you like a sliding window of elements, and seems like it might be, I can imagine that one might be a bit tough. So yeah, thanks everyone for joining, and I'll see you next week.